of pi over 24 plus the tan of pi upon 8.
Yes.
What you should have done is am I right with the numbers? 8. No, your numbers must be wrong. I apologize. But the two guys that you did get are added. Okay, let me just keep going with this one then, which is 1/6 pi. Now, they have the answer tan of 7/6 pi, but tan of 7/6 pi is the same as the tan of 1/6 pi. So you want to try that one, because I think all you did
All right.
was you just didn't combine them to a single fraction.
Okay.
I mean, because that is right. I'm looking at the question, and that is correct. So I don't know why WebAssign picked that one, but WebAssign has funny things. But that guy is the same value as that, so it's not that WebAssign got it wrong either.
Okay.
If you get time to type that in just to double check what I've said is right.
Yeah. It's correct.
Okay, so they are good. You didn't get 10 right. You may want to have another shot at that, but we're going to be doing that today, so maybe you could hold off on that one.
Yeah, that one.
No, we're not doing that today. We did that at the beginning of yesterday. What am I talking about? Yeah. So you got the right bottom number, but your top numbers are screwy, so you might want to figure out if it's a plus minus issue. One of your fractions might have been a positive when it should have been negative, or vice versa. The fact that you get the bottom fraction correct and you got a root 5 correct is promising it. So you really just need to maybe double check your signs of each of the fractions you were using. Hi, I was going to call you there Cooper there for a minute, Katie. Sorry about that.
That's okay. All the teachers call me.
We are talking about siblings. Where are you in the sibling game?
I am the 5th child.
Out of?
Oh, 5. Sorry, I'm the youngest.
Oh, you're the spoilt one then, right? We were talking about your position in relation to the others. So you're the spoilt one.
Yeah, I don't.
Do you agree with that?
No. I make my parents not spoil me.
Okay, so
it's really hard, actually. It's really weird. I like it to all be fun.
If it's out of 3, then typically the youngest is the spoiled, but the more kids you have,
the less more spoiled they get.
Yeah, I think so. Because those are the kids that, like, by the time you have your 5th or 6th kid, when they're falling down, like, you're not as attentive, because they'll be fine. They'll bounce back. Like, you get less and less worried about them.
Yeah,
does that make sense?
For sure.
Yes. That makes sense. Yeah.
Yeah, you kind of got to learn to live on your own.
So because you're the youngest, did you actually get to meet the older ones? Because in my case, the first one in our family is my brother Billy, and the only real recollections I have of my brother Billy when I was growing up was at his wedding, and so I was about 4, I think.
Wait, how old is he?
Well, right now he's 80.
So, oh wow, you guys are really far apart.
Well, there's a lot of kids, so you're going to be far apart just if you only have one every couple of years.
Yeah. So me and my oldest brother are 12 years apart.
Okay.
Yeah, and so I still get to see him a lot, and he just lives in Bellingham, so.
That's not too bad. Yeah, my brother, he got married and he joined, well, he started off in the coal mines like my dad did, but he left as soon as he kind of finished his apprenticeship, he figured out it wasn't a life for him, and he joined the Merchant Navy. So we never saw him at all. He was gone for, as you can imagine.
Is this love?
Well, I'm not sure we want to hear your singing. I am going to kill you, voice-wise, not anything else-wise. God, that's one of the things you've got to be careful in Zoom. You forget that it's on and we can all hear you. I think I did well with that one, didn't I? I covered that one well. Yeah. As I was saying, my brother, he's the Merchant Navy. I mean, I had small recollections because he ended up living in England. So he was in the Merchant Navy and he lived in England. So I never really got him very much. But I do remember he came back from a journey to Africa. He'd been in Africa and he brought us back this rug which had a lion on it. And I remember that rug because he had it for ages. And he got it while he was in Africa. So I remember that about him. And I remember going to his third wedding because he kind of liked women and wasn't very good at being faithful, I think. So I remember, I don't remember his second wedding. So that one might have happened sometime when I was not aware of things like that. But I do remember his third wedding. And he got divorced from her as well. So he was far too good looking and far too, what's the word I'm looking for? He thought he was the bee's knees. I don't know the phrase in America for that. Do you know that one?
Either being arrogant or
Yeah.
you can use charismatic as like a way of saying it nicely.
Yeah, he was that. He was definitely that. My parents did not blame any of his wives. We knew it was totally him. It was him. In fact, I'm sure my sisters would tell his potential wives that he wasn't a good material to be a husband, but nevertheless, they still married him. So go figure. My dad went and said he only got married because he liked wedding cake. And if that's all it took, he would just buy him some, save a whole load of grief for everyone. But he just didn't do it. He's not married, of course, as I said. And that's probably the best. Yeah, he was, I guess, what would you call him? It wasn't really bad. He was the black sheep of the family. But I mean, he never committed any crimes or anything, but he wasn't one that we were particularly proud of. I think we should get started shortly. Come on. Oops, somebody just arriving and I'm getting the thing set up, so that works well. There we go. Well, good morning, everyone. I apologise about the racket. We're going to be getting it. The guy in the roofs are, I think, trying to dig to China. Yesterday, we looked at using the double angle formula, right? That was our guy. So basically, there is, if you want to find the exact value of the sine of a double angle, you use this. For the exact value of the cosine of 2 times an angle, you use any one of these three. And for the tangent, you use that one. So now we are going to be looking at what are called the half angle formula. And what they do is very similar to this. What they do is they give you a formula to find the exact value of half an angle. So typically, this is an example of question 8, I'm going to do 2 of these. They're asking you to find the 3 half angles, right? The sine of a half, cosine of a half, and tangent of a half. And you're going to be told one of the 3 trig functions. Well, actually, you could be told one of the 6, right? In this case, you're told that the cosine of x is negative 12/13. And just to be awkward, what quadrant have they told us? What quadrant is an angle in the 180, 270 range?
3.
Yeah. So, you know, sometimes they just tell you, don't they? It's a third quadrant, which kind of makes life easy. But if they don't, it's the equivalent of telling you it's a third quadrant. So what you're going to do is very similar to how we did these guys. Now, we're getting to the point now where you agree that there's an awful lot of formulas. And, you know, you may quite reasonably to expect you're not going to memorize every single one. If you did enough trig in the world, you start memorizing these. But you know, as many as you can is good. But if not, at least have these guys on cards ready to go, right? So you know where to use them. So back to this fella. We begin by creating a right angle diagonal. The angle is going to be called x this time. And the cosine of x is negative 12/13, but it's also the adjacent over the hypotenuse. So here is my adjacent, here is my opposite, and here is my hypotenuse. And since I know that that guy is 12 and that this guy here is 13, all I need to do now is fill in the third missing one. It's a nice number. Does anybody want to tell me what that is? You'd use Pythagoras to do it. Yep. It's 5. You remember one of those 3, 4, 5, 6, 8, 10, 5, 12, 13s, or certain combinations that just happen a lot. Right, well, you're pretty much ready to go. Well, kind of. There's a few weirdnesses about the formula. You notice this formula, this one, have a plus and minus thing going on. So we have to decide whether I'm going to use the plus square root formula or I'm going to use the negative one. So let's go hunting for the exact value of the sine of a half x. It's plus or minus, I'm not writing that down yet, the square root of 1, take away the cosine of x, all over 2. And I'll need a new piece of paper for this. We know that x is in the third quadrant, right? And we know that x is between 180 and 270. Do you agree? If I'm going to find the sine of a half x and I want to know if it's positive or negative, don't I need to know which quadrant a half x is in, right? So if half x is in the first quadrant, it's positive. If it's in the third quadrant, it's negative, you know, and so on and so forth. So if x is between 180 and 270, won't a half x be between 135 and 90? You agree? If x is between 180 and 270, won't a half x be half of this guy and half of that guy? Which quadrant are angles in 90, 135? What quadrant is that?
Second quadrant.
Okay, so we now know that 1/2 x is in the second quadrant. So back to my question then. I have to decide plus or minus. Well, since a half x is in the second quadrant, is it the sign positive? You see how I decided it was positive we're going to use. And then it's the square root of 1, take away the cosine, which happens to be negative 12/13, all divided by 2. And that's 1 plus 12/13, all divided by 2. And I'm going to do this on a calculator since they're all nice numbers. I can get away with that. 1 plus 12/13, which is that guy, divided by 2, which is that guy, and make it a fraction. And the answer I get is, you see it, 25/26. 25/26. So, oops. So the sine of a 1/2 x is positive the square root of 25/36. And I'm going to try and see if we can do any style points on that. Sometimes you can, sometimes you can't. I think I can do something with this. Any suggestions how I could make this look a little bit nicer?
Break up the square root bar and then put 5 on top and then
Agreed?
so 5 times the square root of 26 over 26.
Now, that would be, in my opinion, the perfect answer, right? A fraction with no square roots involved. This answer is good. This answer is less good. This answer is less good. I've got a nasty feeling, although you can never tell with everything, that any one of those four would be marked as correct. Right, so, but it's always good if you can get it to there, right? Now, sometimes, can we pretend we had a different question? Sometimes the answer just ends up being ugly, like that. You agree? Nothing worth doing. I wouldn't worry about changing it. Sometimes your answer even is worse than that. So if you ever see a square root inside another square root, that's kind of is dead, right? You're not going to make that pretty, right? There's no way that's going to turn into anything. So don't get caught up in trying to do some clever math. If that's what you get, call it good. In fact, if that's what you get, call it good. But if you see something going on, right? If you say, well, you know, I could do a bit with this one, then you should. So sometimes you've got a lot of work to make it pretty, and sometimes, probably quite a lot of the times, you can't do anything, and that's okay. Now that was for the sine of a half x. The next one is going to be the cosine of a half x, which is a very similar looking formula. It's just 1 plus the cosine of x over 2. Right, same question as before. Oh, I need to use this guy. Isn't a half x in the second quadrant? So what will the cosine of a half x be? Positive or negative?
Negative.
Right. Cosine's in the second quadrant. You see how in this case it's a negative square root. So it's going to be negative the square root of 1 plus negative 12/13 all over 2. That's going to get me 1/13 over 2, and that's going to get me 1/26. Okay, do you think you can make 1/26 a little bit prettier? Yeah, sometimes you can't do anything, and sometimes you can. I agree. I've seen some nods. Wouldn't you split it up like that? Then you have that guy, and then you do that rationalize the denominator thing. And that would be the perfect version of that answer, right? Although WebAssign probably will let that one, and that one slide, I think. I guess you'll find out. So far, so good. Now, the third one. Where's my formula? Come on, there we go. Is the tangent of a half, whatever the angle is, in this case theta, but in my case it's going to be x. And it has a couple of features that makes it different. Would you notice that the formula has no square roots in it? Which means you don't need to decide if it's positive or negative, you just use the formula. And you can use either this one, or you can use this one, right? So the one on the left or the one on the right. Both work, right? Both get you the right answer. But mathematically, if you want it to look pretty, why do you think I suggest you should use the one with the sine theta on the bottom instead of using the 1 plus cos theta on the bottom? Why do you think I'm going that way instead of that way? Any ideas?
Is there a fraction in the cosine?
Yeah, it's easier if that's a single fraction than a 1 plus a fraction. It's just my preference because I like to avoid fractions when I can. And I think fractions on the bottom are bad, but fractions plus 1 in the bottom are worse. So since I've chosen to do the one takeaway cosine x over sine x. I need to go back to this diagram because I haven't figured out what sine x is. And sine is opposite over hypotenuse. Now, is that positive or negative? Well, doesn't it depend on what x is? Not what a half x is, because we're doing the sine of x. And since x is in the third quadrant, what will the sine of x be? Positive or negative?
Negative.
Negative.
Negative, right. So we have 1 take away negative 12/15 all over negative 5/13. Would you agree that's probably a good candidate for the calculator? Right, so let's see if we can make it harm. I'll put a bracket round it. 1 take away 12/15, close the bracket, divided by, put a bracket round it, negative 5/13. And I put too many brackets in, didn't I? That's good. Yeah, I put in too many brackets. There we go.
Why did you do negative 12/15?
Because I made a mistake. Because isn't negative of a negative a positive?
Yeah, and also, wait, wouldn't the 15 be a 13 as well?
Sassafrassen.
I'm
Yes.
sorry.
No, you're not. You shouldn't be anyway, even if you are. Right, here we go. Boom. That looks, oh well, it is what it is. And it's negative. I guess it's not as weird as I thought it was.
This is all supposed to be under square root, correct?
Not for the tangent.
Oh, okay.
It doesn't have a square root, and it doesn't even have a, do I make it plus or do I make it negative choice? Whatever the answer comes out to be is what it should be, right? So that's the kind of two things that make it a little bit different. No square roots in the formula, and you don't need to decide plus or minus. Okay, so apart from the last one, which was kind of messed up by me, we got the flow.
Wait, so is
it
okay,
have to be
so I had negative 5. Oh,
Say again.
Does it end up being
negative 5.
It's a negative 5?
That's a 27.
Because it's in the second one. Yeah, but it's negative 12/13, not negative 12/15, and then you end up.
Oh, flipping dipping 7.
I got negative 5 as well.
Yeah. Okay, we're on the same page at least, so I think it's good.
I am getting the world record for screwing up a question that should never. What's she doing? Oh, hold on a second. Chloe, come here, hon. Come on. Come on. Come here, girl. I know. That's not good. Come here. Okay. Oh, oh, come here. Come here. I got you. I got you. I got you. Oh. Oh. Right. Let's pick you up. Oh, there we go. Okay. This is poor Chloe. She just had her operation yesterday, and she does not like the guys battering on the roof. And she went right under the table where all the electric cables were. And I did not want her to get hurt. So we'll give her a little attention for a minute. Does she not look cute, even if she has drugged out? I know. Do you know this little collar thing? It looks like, do you know when you go to the airport and you put collars on and you're in the sea? And this is like the cone of Shane. This is the modern version of it. So it stops her getting to her stitches. You okay now? I put you down? Okay. Oh, I'm sorry. I know you don't want to go. There you go. Okay. Right, once this class is finished, I'll figure out what the wires she's done, because my keyboard is trying to leave the table and my overhead camera has moved quite a bit. So she was under there longer than I wanted. Anyway, this question should have been a lot easier if I could just keep track of the numbers. As you all know, I'm easily distracted, so you can imagine where my brain is today. So let's do one more of these guys. Right, so we're going to do find the sine, let's call it theta this time, a half theta, the cosine of 1/2 theta, and the tangent of 1/2 theta. And this time I'm going to tell you that the secant of theta is equal to 4. And I'm going to tell you that theta is in the 4th quadrant. Okay, so we're going to go through the same process as we did with this one. Now, sometimes they don't tell you what you want. What you really want is the sine, the cosine, or the tangent, right? You don't really want the secant, but we've seen this before. Are you okay with that now being 1/4? So if the secant is 4, won't the cosecant be 1/4? Now that allows me to build my triangle. So there is theta. And this guy here is going to be adjacent over the hypotenuse. Here is the adjacent. Here is the opposite. And there goes my hypotenuse. So I've got a 1/4, which makes this guy, I believe, the square root of 15. So far, so good. Right. Now, I know that I'm going to be having to choose pluses and minuses in a few moments from now, but before we do that, let's just find what the sine and the cosine are, because no matter which one we're getting, we're going to use those guys. The cosine we know. The sine of theta, right, is opposite over hypotenuse, which is the square root of 15/4. Is the sine of theta going to be positive or negative?
Negative.
We know it because of that guy. So far, so good. Now, to decide pluses and minuses, don't we need to know which quadrant 1/2 of theta is in, right? Now, we know angle theta is in the 4th quadrant, right? But which quadrant is a 1/2 theta going to be in? And if it helps, if you're in the 4th quadrant, isn't that the range? You're somewhere between 270 and 360. So where would you be if you were talking about a 1/2 theta? I see somebody pointing at 2. 2, right? 135 to 180. Agree? 135 to 180. So we know this is going to be in the 2nd quadrant. Right, I think we've got all the things that we need. Let's see if this works out a little bit smoother. The sine of theta is going to be, the sine of a 1/2 theta is going to be in the 2nd quadrant, so that makes it positive. The square root of 1, take away a cosine, divided by 2, which is 3/4 divided by 2, which is 3/8. Are we good so far? Now, if you want to make that pretty, God in Himmel, it's going to be the square root over that, which is over 2√2. If you take 2√2 and you rationalize it, you get square root of 6 over 4. There you go. That's the prettiest version of that answer. I'll move on to the cosine then. Will the cosine of a half theta be a positive or negative answer?
Negative.
Right? Correct. And so it's going to be 1 plus the cosine over 2, and that's going to get me 5/4 over 2, which is going to get me 5/8, and that's going to get me eventually the square root of 10 over 4. Eventually, you'd have to do that kind of stuff. And last but not least, the tangent of a half theta. And I like the first one, so I'm going to stick into that. So it's going to be 1 take away the cosine divided by the sine. And that's negative root 15 over 4. So it's going to be a 3/4 on the top and a negative root 15 over 4 on the bottom. The 4s basically cancel out and you get that. And if you want to make it look a little bit prettier, you get that. Oh, and they cancel. So you end up with negative root 15 over 5. Does that look good? I mean, it's basically all I'm doing is shooting through the, the calculations after that. But does that look good? If you disagree, so we'll call it good. So if I went and said to you, I don't know, the sine of theta is a half, find all 3 half angle formulas, do you feel comfortable about how to decide what quadrant it's in, whether it's a plus or a minus? Plugging in the numbers, and probably the most awkward bit is going to be making it look pretty. Some questions just don't lend themselves to be easily simplified.
I have a question.
Yes.
So on WebAssign, is it gonna require us to make it look pretty?
Oops. It might or might not. WebAssign is touchy. Sometimes it is very fussy and it will expect you to, and other times it won't. But even if it doesn't, will you make it look pretty for me? Because it's good math, right? Just good math to get into that habit. Because, if you're moving on to your higher levels in math, you're going to find out that what I call style points is kind of universal. That's what we expect from you. You know how, like, analogy, wouldn't we expect you in algebra to factor things if you could factor? Wouldn't you just take it for granted that you would do it? Wouldn't you take it for granted that you would collect like terms, right? You already are expected to make things look pretty. So this is just, a fancier version of that same process, right? Really ugly square roots, fractiony things can be made nicer, and they should. It makes comparing answers much easier if everybody gets the same answer. It's not good when the French stop here, the French stop here and the German stop there, right? It's not good for the math world. So we all have kind of agreed, do style points. So even if WebAssign doesn't like you, doesn't mind you not doing it, try as best you can to do it anyway. So the next
I
one.
have one more question.
Oh, sorry. Yes.
So if theta is in quadrant 3, then the half theta is going to be in quadrant 2, correct?
Yes,
And then same thing with 4, it's going to be in 2, and then 2 is in 1.
one.
And
Yeah, 2 is going to be in 1, and 1 is going to be in 1.
Okay.
So the half angle will only end up being in the first or second quadrant, right? Provided your angles are only from 0 to 360, which we can assume they are, right? Your original angle could be anywhere in the first 4 quadrants, but the half angle ends up being either in the first or the second. Does that make sense? If you half it, you only get half the shape. Are we good? Right. Now, there are a bunch of questions also using the half angle formula. So let me write down their numbers. Questions 4, 5, and 6. Is there another one? Of course there would be. Question 7 asks you to find the exact value of, well, let's pick one. We're being asked to find the exact value of the sine of negative 285 degrees. Now, these questions will not involve right-angled triangles. They will, however, involve unit circles. And if I've got my unit circle handy, that would be great. Oops. That's asking a lot from me. Nope, is it over here maybe? Is it over here? Okay. Can you imagine my hand as a unit circle? Because you're going to be using it in a minute. How do we find the exact value of that? Well, you use the half angle formula. That guy is 1/2 of whatever 285 is when you double it. And that is negative 570. Now, if I'm going to use a unit circle, would you agree that that guy there is not the guy I should be using? Because he ain't in a unit circle. So the unit circle that I've got over here, can you all see it nice and clearly? This one, right? Only goes from 0 to 360, right? And it's positive. Now we've done this before, so let me do this as a kind of side job. I want to find what angle is the same thing as negative 570, but I want it to be in my unit circle, okay?
75 degrees.
Well, I don't think there'll be a 5 in it. If I add 360 to this, right, so I'm doing negative 570, and I'm dividing, I'm taking away 360, and I try that again. Negative 570, and I add 360, I get to negative 210. Well, that's not good. But if I add another 360, I should be good.
It's 150.
Yeah, that's it, 150.
I got my
So-
75 degrees because I subtracted, or I took negative 285 plus 360. But
Gotcha.
it's not.
So 150. So essentially, isn't that our theta? So we are going to be using the sine of a half theta guy. So the sine of 1/2 theta is equal to, well, we'll talk about the plus and minus in a minute, but right now it's
I have a
going to
question.
be, yes.
So did the problem only say that the value of the value of y is sine of negative 258
285.
or 285. How'd you get the sine of 285 is equal to the sine of 1/2 of the sine of sine 1/2 of negative 570?
Well, if you double that, you get 570.
But how'd you know it was using the formula for the half angle?
Oh, because the question says use the half angle formula.
Oh, okay.
I wouldn't have, well, I mean, I could have guessed, but you know, there's lots of ways of doing that. Couldn't I do that two numbers that add or subtract? They get me 285 method as well. But they did just tell me it was a half angle formula, so should have said that. Now, here's a big problem. I mean, it's just a plus or minus choice, but it's a problem. Forget about what we did over here for a minute. I just need to know is the sine of negative 285 degrees, right? That guy, the original question. Is that in the first, second, third, or fourth quadrant?
First,
Right, if you add 360 to it, let's check that out. So if you go negative 285 and you add 360 to it, that'll tell you where it is. And do you agree with them? Isn't that a first quadrant? Now, since it is a first quadrant, doesn't that make this answer positive? Do you see even that little decision about is the thing going to be positive or negative isn't very clear, right? You have to look at the original, forget about this, and say, okay, will the sine of negative 285, will that be positive or negative? Well, the only way you can really tell that, isn't it, is figuring out which quadrant it's the same as, right?
Wait, so you know, like the last questions, when we did the half angle of it or the half theta of it and the theta, they were in two different quadrants.
Yes.
So how are these in the same one?
If this is in the first quadrant,
Uh-huh.
right, won't half of it be in the first quadrant?
Okay.
So are you saying how come this is in the second quadrant and that is in the first? Is that your question? I'm trying to think of what your question is.
Well, yeah, just because like the other ones that we did earlier were like they were always different. Like they were in the second and third or in the fourth and second.
Yeah.
And so I was wondering if that was the same thing or not.
I think this is just the way the question is working out, in the sense that these numbers turn into that I. Okay. I can't think of a good reason to explain why that's happening. I'm just trusting that it's fine, that it works.
Okay.
Not a great answer. I could argue, isn't 150 also the same as 30 degrees, which would make it the first quadrant?
Yes. I was just thinking that 150 was in the second quadrant, so that's why I was thinking that.
Yeah, it is.
Yeah.
Yeah, we're not using it in the same way we did the earlier ones, right? We're using this in a kind of different direction, and that might be part of the problem. Well, we are going to be using one takeaway, the cosine of theta, which is 150 degrees, all over 2. Now that unit circle that I happen to have, what is the x coordinate of 150?
negative root 3 over 2.
Oh, okay. So take away negative root 3 over 2. Now this fella is going to become 1 plus root 3 over 2 over 2. And really, whenever you see a square root inside a square root, isn't the question kind of dead for style points? I mean, if you wanted to, I'm not saying this is an improvement because I'm not even sure it is. Couldn't I write that down, but that's just as ugly. Right, you can't fix that, right? It's broke. So 1 plus the square root of 3 over 2 over 2 gets us this guy. Now I need to know what the cosine of a half theta is. And it's a plus or minus formula as well. And it's going to be 1 plus the cosine of the angle. all over 2. And we have to say to ourselves, similar kind of question. What is the cosine of negative 285? Well, won't that be the cosine in the first quadrant, which means that this is positive? And it's 1 plus a half over 2, which is 3 halves over 2, which is 3/4. So the cosine of negative 285 degrees is that. Is this one fixable? Can I do some style points on this one? So I'll split the
Yes.
square roots. Yeah. Quite a nice answer, actually. And a little bit worrying. 1 plus, can't argue with that. My half is correct. My half is not correct. It's 1 plus square root of 3 upon 2 over 2. That's much nicer. Right, now I'm happy. I was worried about that answer because it was just too nice. Don't you sometimes get worried when the answer comes out too nice? And I was right to be worried about that answer. I didn't use the correct value for this fella. It should have been root 3 upon 2, and now it works. Well, go for the tangent. The tangent of this negative 285 degrees is 1 take away the cosine, which we had a minute ago, root 3 upon 2, all over the sine, which is a half. And what does that get me? Well, it's the same as multiplying by 2, really. And that's quite a nice answer. That's that one done. So we can use the half angle formula to find the sines or the cosines or the tangents of unusual angles. So let's see if I can find. Wonder why all my questions are negative. Let's do a positive one. I would like to know the cosine, just the cosine of negative, not even negative, positive 22.5. Let's make everything positive. (22.5) is 1/2 of 45 degrees. Great. Right, if you double this, you get that. So we are going to be using 45 degrees as our theta in this formula. And since I'm only interested in the cosine, it's going to be this one here. For the cosine of 22.5, would you agree that this is in the first quadrant? And since it is in the first quadrant, it means I'm going to use a positive answer. And it's going to be 1 plus the cosine of 45 degrees over 2. And it's going to be 1 plus root 2 over 2 divided by 2. And I'm going to call that 1/2 plus root 2 upon 4. Are we cool about that?
I have one more question.
Go for it. Yes.
So do we have to write it as one square root of 1/2 plus root 2 over 4, or can we leave it as the square root of 1 plus root 2 over 2 over 2?
In my opinion, both of those are equally ugly, so I don't care.
Okay.
On the other hand, I wouldn't leave it like that. I would expect this, right? So you have to take each one on its merits, right? These two look equally ugly. Would you agree, just looking at them? Would you agree that's nicer than this? Right? So you just look at what you've got in front of you and say, can it be made nicer? And if you can figure a way of doing it, you should do it. If you think, nah, what I'm going to change it into is no better than what it was, then you can just leave it alone. How about this problem? Let's do radians rather than degrees. Three-eighths pi is 1/2 of somebody. Agreed? Don't we need to know who the somebody is? Because that's going to be the theta that we use for our formula, right? What is the missing angle here? 3/8 is 1/2 of what? And it's not 3/16. What is going to go here? What do you do to 3/8 to get this answer here?
Is it 6 pi over 8?
Right, you double it. And sometimes when you double something, it becomes 3/4 pi. Are we good on that? What about the sine of 7/12 pi? What would the 7/12 say again?
14/12 pi.
And 14/12 become eventually 7/6, so you're correct.
I was just going to say with the last one, I got the same answer of 3 pi over 4, except I converted it into degrees and then doubled it. So I got 135 degrees, which is the same.
Which works as well. Since we're using a unit circle and the angles that you're going to work with are going to be on your unit circle, I don't think turning into degrees is necessary. Can you just find the sine of 3/4 pi and the cosine of 3/4 pi, and it's in your unit circle? It's not a big deal. But there's nothing wrong if you want to turn it into degrees because you're just more comfortable dealing with degrees, and nothing wrong with that. Do that as well. For the last one, how about this? Looks just like that one. And it ends up being that guy. But that guy isn't any good to me. Because if I'm going to use a unit circle, don't I need an angle that's 0 to 2 pi, right? So we're probably going to end up back with your problem of how come this is in a different quadrant than, you know, what we did at the start of today. Where would -3/4 pi be? Which quadrant?
5/4. So quadrant 3.
So we're looking at 5/4 then, right? Over here somewhere, right? So do you see that sometimes you have to manipulate the numbers to fit the unit circle? So in this case, theta would be 5/4 in all the places I'd use it, right? Sines and cosines. And since this is -3/8, this is a different question now. Which quadrant is this guy in? I know 5/4 is over here, but where is -3/4? 1, 2, 3, or 4? Which quadrant is this going to be in?
4.
Yeah. So you're going to have an angle on this side that's a 4th quadrant angle, and you're going to be using these guys here, right? You're going to be using a 3rd quadrant angle in here. You see that the two are different quadrants, right? The half, the other, whatever you want to call it, this guy here, and the other guy are in different quadrants. And so you just have to know, specific to the question, which quadrant each bit is in. So theta is in the 3rd quadrant, right? But the original angle here is in the fourth quadrant. So since this is in the fourth quadrant and it's a cosine, wouldn't I be using a plus square root formula? Even although theta is in the third quadrant, and so when I plug in, the value of cosine, won't it be the cosine of an angle in the third quadrant, which means that number will be a negative one, right? When you go to your unit circle, you'll have a negative there. And I think we have came to a nutshell.